So we're talking about JWT misuse and abuse. I read a lot of code. Carolina Code Conference is a conference that I've spoken at recently, and it's my whole life has just been writing code. I absolutely love it. Even though I'm a web application security professional now, programming has been a huge part of my life at pretty much every single step. And I would say, little mentorship sidebar here, if you don't know how to code, you don't even know how to cobble together a simple script, I highly encourage you to do that. It will make you more effective and more efficient at every job you do, period. I was talking to you last night at dinner or yesterday afternoon just about, when I first saw Daniel, I was really pushing Python. Probably gave this same exact comment to him and a couple of other folks. He ran with Python, has been doing it for years. And how much more effective has that made you, Daniel? I would imagine almost indefinitely more effective. Every job I've ever had, whether it was managing spreadsheets or whether it was actually managing a network or doing security, the ability to code has been absolutely huge. So let me encourage you to do that. But I do a lot of programming. I also do a lot of security testing. JWTs is one of these things that I come across all the time. If you're dealing in web application security, you come across them too. Now, the more known thing about JWTs is obviously the crypto stuff. I've been focusing on kind of the non-crypto side of things, more of the implementation stuff lately. And so that's what we're going to talk about today, is just share you some of the things that I've explored, some mistakes that I've made, some just interesting behaviors and implementations that I've come across. And so that's the goal for today. Okay. Now, I think what best defines a person is why they do things, not necessarily what it is that they do. So here's a slide here of some of the things that I do. But the reason why I do it's a little bit different. Some people are chasing celebrity and popularity or notoriety. Some folks chase money. They want to make that first million or whatever it may be. For me, it's largely about serving. Okay, so if you've never heard me say it before, if you've ever heard me say anything before, I am a one-trick pony. I only got one skill. I do one thing, and that's web application security. Now, I do it pretty well, okay? I'm good at my trick, but I only do one trick. And that thing, I believe, is a gift that was given to me by my creator, okay? And so I serve him by taking that gift and using it to try to make the world a better place. And part of making the world a better place is trying to teach other people everything I know about that one thing. And so a large part of my company is training, teaching, mentoring, coaching, those types of things, as well as doing the consulting and some of the other stuff. So here's a little bit of stuff about me. Large part of my career, especially on the security side, has been my time in the service. If Chris Case is in the room, he was huge and instrumental in my coming up. We were on the Army Red Team together. He taught me a lot of what I knew early in my career. There were plenty of people also involved at that point, but the time I spent in the military really cut my teeth on security. Daniel as well also has had that same sort of experience. So I'm a veteran, husband, father. Those are major parts of who define who I am today. Do a lot of coding, a lot of breaking, a lot of teaching. Solopreneur, I'm like a one-man show. I run a lifestyle company. You ever heard of a lifestyle company? Right, it's a company that just kind of lets you live the kind of life you want to live rather than a sole focus of making a whole lot of money or becoming a big business. I don't want to grow. It's just me, but that's what I do. I am a Board Swigger preferred trainer. So we're going to use Burp Suite Pro today. If you're in here, you do web application security, you haven't heard of Burp Suite Pro, definitely need to get on board with that. Burp Suite Pro is the de facto standard tool for our craft right now. Don't know that it will always be, but it is right now. I am one of their preferred trainers, and I do have a class coming up in the next couple of weeks on Burp Suite Pro Advanced Tactics. And basically, Burp Suite Pro it's a very capable tool. It was designed largely for server-side rendered web apps that were designed in the mid-1990s or so. So modern web apps cause a lot of problems within Burp. I've written a class where we take Burp and we kind of bend it to do the things that we need it to do to handle modern application problems. Teaching that class coming up here in the next couple of weeks. If you're interested, practicesec.com is my website. That'll be later in the slide deck. You can definitely check it out there. But if you're looking to take your Burp stuff to the next level, I promise you take that class, you're going to learn some things you did not know before. It is what I believe to be the most in-depth Burp class that's available. Power's not going to go out. Power's gone out one too many times in my life over the past couple of weeks. So let's not do that again. Okay, anyway, actually this little quote right here is not my quote about myself, by the way. That was actually a student I had in my class at Wild West Hackin Fest, the first one in 2017. He took that class, and we were sitting at dinner one night, and he's like, hey, Landmaster, the Burp Suite Master and King of making HTTP requests tremble. And I was just like, I like that tagline. I'm going to start using that. So I put it in the slide, and it's been with me ever since, but that originated right here at Wild West Hackin Fest. Okay, so here's the outline that we're going to do today. First, we're going to talk about a little bit what JWTs are. Like, what are these things? Why they matter. So we'll chat a little bit about why they matter. If you guys already know what they are, that's cool. I might give you a few nuggets. Otherwise, that might be a little bit of review there. We'll jump into some use cases, talk about how JWTs are used, and then I'm going to jump into a couple of specific misuses and abuses within a few of these categories that you see listed here. We'll conclude, talk about some remediation, the right way to do some things, or the right way that we recommend our clients to do some things. Cover a few resources, give some credit where credit's due based on some of the stuff that I used here in the presentation, and that'll be the end of it. So JWTs and claims. Anybody here ever read raise your hand if you've read an RFC before. All right, so quite a few. I'm not the only nerd in the room then, that's good. I would hope that these rooms should be full of nerds, right? Or geeks, as I like to say it. So yeah, if you ever need a nap, or you want to learn something about a protocol, read an RFC. Because you're guaranteed to get one of those two things. You're going to fall asleep or you're going to learn something. Those are the two things that happen when you read an RFC. So RFC 7519 is the one that defines JWT. Now, there are some others that kind of augment 7519, but that's the main one that defines what a JWT is. And it defines it as a compact, URL-safe means of representing claims to be transferred between two parties. Now, one of the things I want to focus in on here is this idea of URL-safe, right? Well, we're going to be talking about JWTs as they're used within web applications. And web applications communicate over URLs, right? So that makes JWTs a very nice, very good thing to use, or makes it very easy to use within web applications because we're already using URLs. It's URL safe. It's kind of a match made in heaven there. And they transfer these things called claims. All right, so what is a claim? Well, RFC 7519 defines a claim as a piece of information asserted about a subject represented as a name-value pair. So a name-value pair is basically just a name and a value, right? You see them all over the place. You see them in parameters. You see them in JSON properties. You see them in headers, right? Just a name and a value. Very, very simple. And you see that identified in here at the bottom. You see a couple of different name-value pairs that are there. Those are what we call claims, and they're assertions about a subject. So when you're talking about a JWT has what we call a subject. It is the things that it's saying have to be about something, and that thing that the claims are about is what we call a subject, and that's what the SUB claim stands for there, short for subject. We'll talk more about that here in just a second. Now, when you have more than one claim within a JWT, you have what's called a claim set. And you can see that down here, a claim set. And if you've ever seen a JSON object or a JavaScript object before, that should look really, really familiar because that's what it is. It's a JSON object, which is where we get the JSON and JWT, right? That's what it is. There's a couple different types of claims that you can have. There is a registered claim, public claim, or private claim. If you're interested in the specifics of that, I'll tell you to just go check it out on the RFC. There are basically just pointers, ways that you should use certain claims, but none of it's like restricted and mandatory. You can use them for however you want, but if you're interested in interoperability and making sure other systems can read your token and know what you're trying to say, then of course you probably want to conform to the spec there and use registered public and private claims for their intended purposes, okay? All right, so if they're just like basically JavaScript properties, then why do we call them claims? Okay? Well, when we're dealing with claims, we're dealing typically with a couple different parties. There's an issuer that claims something, and we talked about the subject itself, to an audience. And there's quite often what we call an intermediary somewhere in that particular relationship. So the issuer is going to make a claim about the subject that is going to traverse through some sort of untrusted intermediary, and then eventually get at the audience, which is going to process that particular JWT and do something on behalf of that information. And it's not truth at that point in time, right? It might be true at some point in time in the future, but at that point in time, it's just a claim. The issuer saying it about it, but since it's coming from an untrusted source, it's not truth yet. Okay, it's not a defined and a proven property at that point in time. And so we basically use like we would in the English language. If I just make a claim about someone to someone else, that's all it is. It's not necessarily true until that person goes back to the original source and says, hey, someone told me this about you. Is that true? And then if it is, okay, now it's trusted data. But up to that point in time, it's just a claim I'm making. And so that's why we call it a claim and not a property, because it's not actual truth yet. And as you can see in this graphic here, there's an example of that. You have an authentication server, which is basically an issuer. And then you have the resource server, which is the audience. It's going to do something with it. And then you've got this client over here that's an intermediary that's actually going to be authenticating to the issuer and then passing the resulting JWT on. But that client, we know the client's always untrusted, right? It's an untrusted intermediary. This is just an example. This isn't every use case for a JSON web token, but this kind of helps to see and visualize the concept here of why we call these things claims. Okay, so obviously, though, what's really important about these things is if we're going to actually turn these claims into truth, into fact, then we've got to verify the integrity of the claim. Right? We've got to be able to verify the integrity because a claim should not be trusted unless there's a couple of different conditions are met. Number one, that the origin of that particular claim is a trusted origin. Right? That the resource server, that the person that's using the JWT actually trusts where it came from. And then number two, that it has integrity. That not only do they trust where it came from, but that it hasn't been modified at some point in time. Now, raise your hand if you're familiar with the security triad of CIA. All right, most people in here, security conference, of course, right? Confidentiality, integrity, and availability, right? So what is it? Integrity ensures that something hasn't been changed. So what is our security control that we use to ensure integrity? It's some sort of signature, okay? Some sort of signature. And so within the JSON Web Token spec, you've got two different structures of a JWT that you'll have. You'll see a JWS and a JWE. If you're looking, in most of the JWTs that you're going to interact with are what we actually call a JWS structured JWT, which stands for JSON Web Signature, because it's a built-in mechanism that effectively enforces integrity and makes sure that this thing, even though it may have gone through an untrusted intermediary, can be verified as not being changed. And so what you see here before you is a JWS, structured JWT, and it's split into line breaks, so it would actually be all joined together in one line in most cases, but it's split out to C. And you basically see your claim set here in green, right? That's your claim set. And then you have a header which tells the audience that's eventually going to receive that particular claim set how to actually the algorithms and stuff to use to actually verify the signature. And of course, you have the signature at the end of it. Pretty straightforward. If you've ever dealt with JWTs, this is likely the way that you've seen them as a JWS, because this is the default when you're dealing with JWT libraries. But integrity isn't always enough. In most cases, it is. In most cases, just validating integrity is all that you really need to do with a JWT, but sometimes it's not enough. And that's because JSON Web Tokens, or at least in the JWS structure, are what we call transparent, okay? So transparent means I can decode something to see what's inside of it. Opaque is the opposite of that. It's where I can't decode it to see anything. I can't turn it into anything without some sort of other mechanism, right? But with a transparent piece of information, I can see what's in the information, and JWSs are transparent. So sometimes, we'll talk about some examples here in a little bit, but sometimes not even the user themselves should be able to see what's inside the token. And if that's the case, then we need to do one of these other pieces of the triad, which is to ensure confidentiality of the information that's within the JWT. And when we need to ensure confidentiality, that's when we see this other structure, which is the JSON Web Encryption structure. So you see a breakdown of that here, similar to that you did the JWS. And just know that the JWS is actually the yellow part. Yes, the yellow part, okay? So the actual JWS now gets encrypted using all of the other variables that you see that are a part of this JWT. And once again, those are pieces of information or variables, if you want to call them that, inputs into the encryption process that the audience receives. They take the shared secret key or whatever it is, they're able to decrypt the JWS, then validate the signature of the JWS, and now you have confidentiality and integrity enforced on the claims that are held within it. Okay? So we got integrity and we got confidentiality of these things called JWTs, but why the heck do they matter? I think thanks to them for teaching us about JWTs. Now tell me why I need to care about that. And that's because they are a core component of modern applications. Who here actually deals with web applications regularly, right? Quite a few of you. Have any of you not seen a JWT before? Like, Probably not, okay? In modern applications, right? In fact, most that are being developed in the last 5 years or so, the trend, in fact, over the last decade, has been to use, like a microservices architecture on the back end that's doing all authentication and authorization through JWTs. And then you got like a front-end client that's written in some sort of framework, and it just talks cross-origin to some API. And it's JWT being passed around between all these different services to authenticate. So if you're dealing with modern applications, you've probably ran into these things, even if you didn't know what you were looking at, you've probably seen them before. Okay, so they're everywhere. Now, the problem is that the spec is actually really poorly designed from a security perspective. All right, so immediately in 2015, when the spec was officially released, immediately the none algorithm was reported. Now, if you go through and you read the specification, it literally says at one point in time, if you go into the header and you just tell it to use the none algorithm to calculate the signature, the audience will just ignore the idea of calculating a signature altogether and just process the claim. So on day one of this particular spec, you could actually just modify JSON Web Tokens at will and send them to the server and bypass any type of security check, all right? Immediately on day one. That was obviously a really bad thing, right? Well, 8 years later, tons of crypto vulnerabilities have been talked about at different security conferences about this. And then Black Hat, not this past year, a couple months ago, but last year in 2023, 3 more crypto vulnerabilities within the JWT specification were talked about at the conference. So, like, crypto has not aged well with JWT. It's a very poorly designed spec with regards to security. And so if that's the case, then why don't we have an alternative, right? We should have if this is so broken, and it has been now for over 9 years, why don't we have an alternative? Well, there's a couple of different reasons. Number one, there actually are alternatives. There's these things called macaroons, which were developed by, I believe, Google, okay? There's another thing called Pacetos, and these are actually probably better and more secure, more interoperable solutions than JWTs are, but the problem is they don't have an RFC. JWTs have that RFC. And politically, when we start implementing the technologies, the things that have RFCs typically win out as the standard. And what doesn't help is that even if we had JWT as a standard and nothing else used it, we'd have a pretty good chance of getting away with it. But then we have other protocols, other standards that then include JWT as a standard within their own. So OpenID Connect, which is an authentication protocol built on top of OAuth, actually requires that the result of that process be a JSON Web Token. And so now we have this broken spec built into other specs. And if you're a developer and you're building OpenID Connect into your application and you're already using JSON Web Tokens to do that, why would you just say, okay, I'm going to use JWT over here and then I have to go learn and implement some other technology over here just simply because I don't want to use JWTs? You're probably not going to do that. You're just going to use them everywhere. And so basically, if you think of this idea of forced adoption, that's where we've ended up. Forced adoption. We have to use them because they're built into so many other specifications that we use. And that's kind of where we're at. So they're here to stay. Okay. They're here to stay. Developers need to be able to implement them securely. And then we as testers need to be able to determine when they're implemented securely and then help developers understand them better from a security perspective, not just crypto, but implementation as well. All right. So some use cases for JWTs. The 3 primary ones that we're going to focus on here are use cases in authentication, authorization, and information exchange. And if you think about it, like information exchange kind of includes every single JWT because we're passing claims, which are by definition information. In fact, pretty much I'm just treating that as a catch-all for everything that doesn't fall into these other 2 categories. But those are the 3 that we're going to focus on here. And our approach is going to be that we're going to talk about each of these categories, at least do one example in each of them. We're really just going to focus on my favorite examples, both because, mainly because of time, right? But also because that's all I've got built into our environment that we're going to be working with. We're not going to talk about crypto-related vulnerabilities. Like the open domain of information is full of a plethora of information about about crypto vulnerabilities in JWTs. In fact, I would point you to Hornsberger's Web Security Academy. Their section on JWTs goes way further in depth on the crypto side of things than I could ever go into in a talk that's 50 minutes long. Okay, so I highly encourage you to check out that block of instruction. Go there and do that. In fact, mentor tip number 2 would be become a practitioner level completionist for that entire Web Security Academy. That is just a great starting point for anybody that's looking to get into the field. Do that, and then come take JWAPT, which is my class, which is going to teach you all the things that Bert doesn't teach you, basically. Okay. Because Bert really focuses on injection vulnerabilities, or Portsberger focuses on injection vulnerabilities and things like that. I focus more on process, authorization, authentication, and those types of mechanisms. But regardless, that's huge. Check that out. I'll let them teach you that, because if I find less open domain information on the implementation level stuff that we're going to talk about in here. Now, I'm not dropping any zero-day vulnerabilities. Okay. The stuff that we're going to do and talk about and the demos that we're going to do, it's not new. Like, they're out there. I just don't see them talked about nearly as much. And I find them more than I find crypto vulnerabilities, because libraries just have fixed themselves at this point in time. And we'll talk more about that a little bit later as well. Okay. So now, the other thing I want you to keep in mind is we go through these demos, the techniques that we apply in the demos are going to be specific to a particular category, but they're in no way unique to that category. They can be applied anywhere. So we're going to talk about a particular technique against a particular category and type of token, but just know that that technique will also work in other areas as well. That might make more sense once we get into it. But basically, the techniques, they're universally applicable no matter what type of JWT that you are working with. Okay, so the first category is authentication with JWTs. Okay, and most commonly when you're dealing with JWTs and authentication, you're dealing with this thing called an ID token. And this ID token is the result of this OpenID Connect flow. I mentioned that a few minutes ago. It's that authentication protocol built on top of OAuth. Which when you go to a website and you see that log on with Google button and you click that, that is OpenID Connect. And it does a whole bunch of stuff. It may ask you for your credentials and then ask you if you want to allow certain things. And then eventually that handshake is going to pass what's called an ID token from that exchange to the actual resource server, which is whatever resource whatever application you're trying to gain access to. And then that's going to have to process the ID token to verify you. And you see right here, this is literally just copied and pasted right out of an ID token. I don't think that's every claim, which is what the ... is, but those are the claims that most applications are going to look at that come from Google. So this is an ID token from Google. And now my application has the opportunity to take this and either log a user in based on that information or create a new account based on that information, right? So the ID token is what we're talking about here. And it's ultimately just an artifact that proves that a user has authenticated to something you trust, right? If you click the log on with Google button, that application has chosen to trust Google to authenticate you on behalf of them. Is basically what it comes down to, okay? So you've proven, or Google is trying to prove that you've successfully authenticated. Now, when you're dealing with OpenID Connect, there's actually two different ways that they can happen. They call them two different flows. There's this thing called the implicit flow and this thing called the server flow. And the way that you implement them securely is vastly different, okay? Because in the server flow, you don't have to ensure integrity or confidentiality because all the exchanges that happen are between the resource server and the issuing server. Everything kind of happens on the back end. So it's much more secure. There's no untrusted intermediary that's going to be processing that information. The implicit flow is the exact opposite of that. You must ensure at least integrity and in some cases confidentiality because it traverses that untrusted intermediary. Has anybody in here ever implemented an OpenID Connect? Did you use Google by any who here has ever dealt with Google's API documentation? All right, not many hands. Take my word for it. It's an absolute mess. Like when you start going through Google's API documentation, like they've had so many versions over the years. It's almost kind of like a Wikipedia article where you can just start clicking links and it's taking you all over the place. And you're just like in a sea of documentation. It's very easy to get lost in what actual implementation process you're following when you're implementing Google OpenID Connect. I literally created an application that I was implementing the implicit flow, but was actually reading the implementation guide for the server flow that told me I did not need to verify the signature of the JWT. And what ended up happening is I had an untrusted token that was now not being actually validated. And so it could obviously be we're going to actually go through a demo of this in a minute, but it could actually be messed with on the fly. Integrity wasn't enforced and you can log in as anybody you wanted to. But the developers would do this. I'm a security-minded guy and I made that mistake, right? And most developers you talk to are going to agree when you talk to them about Google's API documentation, they're going to say the same thing. Yeah, it's a mess. It makes you really uncomfortable, unsure about what you're doing there. So a question I always ask myself as a security tester, when I see an application using that authenticate with Google button or whatever it is what if the developer made that same mistake? What if they treated an implicit flow like a server flow? We need to test for that. And that's going to lead us into our first demo here. Okay, so what am I using in our environment? I've got Burp Suite Pro, of course. All right. And then I've got an application called OwnHub. You ever heard of OwnHub? Going back to the keynote that was given. I love creating software and giving it away for free. It's a huge part of what I do. I'm in the community. It's good to kind of give back a little bit. This entire environment consists of like 5 different applications. Is all available on my GitHub. I think I have a link to it later on in the thing, but you can set it like if you got Docker compose up, hit enter, and you've got the entire environment up and running on your system. You can play with it to your heart's content. You got multiple different target applications with tons of different vulnerabilities that you can tinker with. Here we're dealing with a server, SPA, single page application. It's got Vue on the front end. It's got a cross-origin API written in Python on the back end. Very indicative of a modern application of what you might run into on a day-to-day basis. So we got Burp Suite Pro, and we've got this target application. Okay, so what I'm gonna do is log in with Google. And this is always fun. I need to refresh the page because I loaded this the first time when I was not online. But I think I'm online now. There we go. We did it. We made it. Now let's do this. I hope I get a text message. It is, isn't it? I feel like a real hacker now. Of course, it didn't answer the phone. It died on me. There we go. Okay, it worked. That's the end of our talk. Everybody hear that? All right, we're logged in. That's the only thing we need an internet for. That's literally the only place a hiccup can happen in this whole talk. And guess what? It happened. That actually happened to me at this conference too, not too long ago. So we made our way through it. That's good. Okay, so here we are. We're at ownhub.com. I've logged into the application. Now let's go explore that particular flow with Google. Or not with Google, with Burr. So I go to my proxy history here. And if you look, all these things going to Google, there's a whole lot going on here, right? That's probably, you see all these tests on ownhub.com. This is me loading up the single page application user interface here. This is that first request out to initialize the process. And then all of these exchanges happen between my browser. These are all just between my browser and Google until I get to this point right here. And you can see there's my ID token that's being sent over to now the application, which then gets processed. This account probably did not exist because I reset the database before this. So it created an account on that user's on the behalf of this ID token, and then logged that particular user in. Okay. And then what it did is after it did that, it gives you an access token once you've logged you in, and that access token becomes a temporary credential. We'll talk about that in a minute. And then it passes that temporary credential over to users.me so that the front end knows who just currently logged in, okay? Because that's how single page applications work. Front end doesn't know who just logged in unless the back end tells it. And this is what it does. And you can see here, Tim Tomes just logged in, ownhub@gmail.com. There's some other user information there. And then I'm able to go forward and access my notes and all the internal capabilities that exist here. Okay, well, let's go back and look at this ID token and see what's in there. And so we can look at the claims here. And it's really hard to see in here because it doesn't give you much window, and I don't think you can drag and drop much of this. Maybe we can. That helps a little bit. There you see all the claims coming from Google that need to be validated by the server, right? Because if I pass in ownhub.gmail.com, that's probably what the application is using to create the account. And so the thing that we want to test here is it actually valid? Can I modify this? You can always modify JWTs. There's nothing to prevent you from doing that. Will the server accept it and take it and not validate it? That's what we want to test for. So we'll take this request and we'll send it over to Repeater. We'll hit send. And once again, that worked. That was the old one. That was the validated one, okay? Now let's go in and change this thing. And let's just say that we were able to enumerate a user admin@ownhub.com, and there's this application is vulnerable to that, so we could totally show you how to do that, but that's kind of out of scope here. We just know that there is another user named admin@ownhub.com, or we're just taking a guess, okay? It doesn't really matter. Point is, we've modified this now, and we do not have the key with which to re-sign it, so we're going to send it with the old signature, the modified body, and see what happens. So when we hit send here, we get an access token back, okay, which immediately is like, okay, if it didn't work, I probably should have got a 400 or maybe a 401 or something like that, but I actually got an access token back, which already tells me it looks like it works, but I want to validate that it actually worked before I just trust it blindly. So now what I'm going to do is I'm going to take that user's me endpoint, send it over to repeater. Once again, this is my old token, which shows that it's Tim Tomes that's authenticated there. So let's go grab this access token from the modified ID token and paste it in as our access token. And we can see that we're logged in as administrator. So it failed to do the signature check on it. It processed it, created a new user based on modified information, and we were able to log in as the administrator as a result. Really basic stuff there. That's not mind-blowing. That's not anything revolutionary or new. It's just not doing the very simple thing that you need to do as a result of maybe reading the wrong documentation or just making a simple mistake. You will absolutely run into those types of scenarios sometimes. Okay, so the next category I want to talk about is authorization. And quite often when we're dealing with authorization and JWTs in authorization, we're dealing with things that we call access tokens. Okay, and there's a couple of different sources about or uses for access tokens within authorization. The first one is the result of an OAuth flow. So I just talked about OpenID Connect being built on top of OAuth. All right. Well, JWT requires the last part of that relationship to be a JWT ID token. They've actually increased or put more restrictions on the OAuth standard itself, because OAuth itself does not require a JWT. It can be anything. As a matter of fact, so I think the result of Google's OAuth handshake is a opaque token. Okay, I'm sorry, an opaque piece of data. It's not a token at all. And so it doesn't have to be a JWT, but quite often it is. Probably the more common place that we see JWTs used in authorization is this idea of a temporary credential. So temporary credentials, most of you probably are familiar with the idea of sessions, right? Where you log into an application, it gives you a session or a session ID, and that session ID is basically a pointer to your information on the server so it can track a stateful relationship between your browser and the server. That's how the server knows it's you every time you make a request. Something inside of that session, right, has to identify you as you. When that session gets to the server's got to be able to look at that and go, okay, this belongs to Tim, or this belongs to Daniel, or somebody else, okay? So it's got to have something that does that. Well, an access token, when we're dealing with like an API on the back end, it's quite often what we use as that stateless temporary credential, where sessions are stateful, right? Access tokens are stateless. So it still has to have something that identifies us as us, and when we pass that token to the server, it now can exercise that logic on behalf of Tim or whoever owns that particular access token. So most of the time when we see access tokens, we're seeing them used in the context of a temporary credential, a way after we authenticate, a way that we continue to re-authenticate to that back-end service, okay? And we often call that a bearer token, because the person that's sending the token is the person bearing it, okay? And if you've ever seen the authorization header and it says bearer and then it has that token after it in the HTTP request, that's where that comes from. It's a bearer token because the owner of it that particular token identifies is bearing that particular token. Okay, so what if a developer, because something within that, actually, so you look here at this example right here. You see the sub there, right? The sub 5. So this is the body of an access token. If we were to go look at the access token in our app right now, this is the claim set that's inside of it. Obviously, right here, the thing that identifies me as me is the subclaim, which stands for subject. That's the subject of the token. That is the subclaim. That's the thing that identifies me as me. And so when we're talking about authorization and we have applications that maybe use multiple tokens in different places, it's possible that they might share a similar claim set. Okay. So I'm using subscriber 6 here as an access token to exercise some sort of logic on the server. But maybe there's another process within the application that also uses a JWT. It's not an access token, but it uses a similar claim that uses subject 6 or subject 1 or subject whatever it is. Can I take a token from one place and use it as an access token? And will it process it, use those particular claims, and then actually cause it to think I'm someone that I'm not? This is a vulnerability that we refer to as JWT substitution. And so specifically what we're going to demo here is taking a JWT that's used for something else and then substituting it in as an access token to actually bypass authorization without having to trick any signature stuff. In fact, I believe we're going to start this and then we're going to make it, we're going to put ourselves as the attacker in the most difficult position, which is going to be a signed and encrypted token. So I'm going to go in here into our application and I'm going to enable signature verification and encryption. So this is the worst case scenario for an attacker. Now I'm going to go over to the application and I'm going to log in with a user called Cooper. Basically, I'm going to become Cooper at this point in time. I'm going to log out. Okay. So it says it sent me my passwordless authentication token. So I'm going to go over and check Cooper's email. This is basically just an in-band way to do email. Okay. So I got an email inbox here. This is Cooper's email inbox. I'm going to grab my authentication token. And I'm going to pass it into my passwordless authentication system, and I'm going to authenticate. Okay, so now let's go in here and let's look at this process, just like we did before. So where's my log out? So here's my delete the access token where I logged out of the previous. Here's my post request. Okay, and this is me providing my email address, and I get a 403 back. And that 403 actually says that the error message is a code required, and it passes this thing called a code token, right? So the next step is that this also triggers the front end to tell me to go check my email. So I go and I check my email, and then you see another post request to access token, which actually provides the code that I got in my email, along with the code token that was just given to me, and it passes it over to the server. The server receives that, issues me an access token, then it goes up to users.me, and sure enough, I leverage that access token and I am logged in as Cooper. Pretty straightforward process. That's how this works. Okay. So the interesting thing about this is the input to this process is Cooper and the output to this process is Cooper, right? Cooper in and Cooper out. But how many different tokens are actually as a part of this process? 2, right? We've got a code token and we've got an access token. So there's one input that has the same output, but yet there's 2 different tokens that are part of this process. So it stands to reason that if my access token on the backside, it belongs to Cooper, and then the code token, which is what was given to me when I initialized the process based on Cooper, that there's going to be something inside both of those tokens that identifies Cooper. And that might be the subject claim, okay? And so that's the assumption that I'm making based on the behavior. So what I want to do now is actually try to log in as admin at ownedhub.com, just like we did a moment ago, except we're not using Google. Let's see if we can spell things right. I'm going to log me in. I think that's what we're doing here. Yeah, okay. So now I don't have the admin's email address. I don't have access to their inbox. So I can't go check the admin's email to get that code out of it. But based on the assumption I just made, can I actually go into my post request right here, take this code token and substitute it for the access token? And if there is an overlap in that claim set, then it might actually work in my favor as an attacker. So I'm going to copy this thing, go back to my repeater request for users.me, which is right here. Once again, I'm going to go back to the original, which proves that actually it's not even valid anymore, which is awesome. That's even better. Let's go in here and put this token in and send it, and I'm logged in as the administrator. So that validates to me right there that that initial code token that was sent is using the same claim as the access token to identify the owner of it as Cooper, and that allowed me to substitute it and completely bypass the need to put in the code. Pretty cool. Definitely pay attention to these substitution vulnerabilities. All right, we'll talk about remediating that here in just a minute. Okay, so there's another version of this that's even neater than this. Okay, and what we're gonna do is we're gonna go and make this a little bit more of a normal use case scenario. So we're gonna turn off encryption, but we're gonna leave a signature on. So this is basically the default implementation of most JWT libraries. Second signatures, not encrypting. So this is not like me breaking things to make it easier. This is pretty standard behavior right here. And what I'm gonna do is I'm gonna go through the process of signing up for an account. That's my actual email address. Feel free to use it if you want to hit me up. I don't care. I'm good with it. I got the spam button. All right. So there I am. I try to do this and it says activation email sent. So then I need to go and check my inbox, and I'm going to get rid of Cooper's inbox because I'm no longer Cooper at this point in time. And so there's my magic link to sign up. I'll hit it. It now says I'm activated, and now I could go through the process of logging in with that particular account, just like I did with Cooper a few minutes ago. Let's go look at that process. So my post request, there's my delete. There's my post request, the admin code required. This is the one I wanted right here, okay? So this, check out this right here. All right, that is my request going from my client to the server to sign up a new user, all right? And then the result of that is success equals true. Hey, go check your email and click on the link. Now, when I go in there and click on that link, it fires off this post request to users, the activate token, which then results in success equals true, which tells me that it just took this particular token right here and created the account. But if you remember back earlier in the talk, I talked about how access tokens are typically used when we're dealing with a stateless system, which means the server doesn't remember anything about the client. Every single request has to include everything that the server needs to do the thing, all right? Which means that the only way that this request can create an account is if the request itself had that information in it in the first place to create the account. So if we go look at this JWT, you'll see this right here. See what that looks like? If we look at that claim set, and I can zoom in, if we look at that claim set right there, it looks exactly like this right here, which tells me that the server is taking that information, putting it in that authentication token or whatever the name of it is that I'm using there, right? The magic token, and then emailing that in a link so that when the user verifies who they say they are within their email and they click it, it just sends all that data back. Okay? Interesting thing. Well, can I just, if I control this initial request, can I just add arbitrary claims to it and see what happens? Well, let's do that. I'm gonna right click this, I'm gonna send it to repeater. Now I'm just going to add an arbitrary claim. Probably need to get rid of it. Okay, there we go. Right there, foobar. Hit send. Tells me it's trying to create the account. Go check my email. So I'll go check my email. Here's my new email. I click on it. And now let's go back and look at this. This is the post request with the activate token. That's what the name of it is. Take a look in it. Notice we were able to forge a token, okay? So I can add arbitrary claims to this token. It's interesting. Can I overwrite claims in the token? Because if I can add a claim, potentially I can also add a claim that already exists, kind of like double it up, and maybe the server will just overwrite the existing claim with mine. And so obviously if we're getting back around to this access token thing, we look up here in this and we see that there is a subject And the subject here is just a generic new user, right? It just tells the server the subject of this token is a new user, take it to create a new user. Well, what if I just use the same behavior I just did to overwrite that subject claim to, I don't know, something like 1, user ID of 1. So if I go back here, this time, instead of foo bar, I'm going to do sub of the integer 1, and that's son, not sub. Yep, thank you. Horrible typer. Success equals true. Let's see what the resulting behavior may be nothing. The resulting behavior may be an overwrite. I wouldn't be talking about it here if it was nothing though, right? All right, so go back to the inbox, click on the latest email, go back into burp. Once again, like, all right, yeah, here I can have access to this email, right? Because it is coming to my user. So here now let's go look at this latest post, which is right here. And sure enough, I've overwritten it. So now I've been able to forge a token that now shares what I know to be the same claim as the access token. And now I can take this and just substitute it in for my access token, and I should be able to be the admin again. So once again, this is it. So let's go back to the original, prove that it doesn't work anymore, or that one still belongs to Tim Tomes, right? I'm going to go back here and overwrite it with this one. I forged token, hit send, and I'm logged in as the administrator. We kind of already knew that was going to work. The whole idea there was just finding this ability to actually forge a JSON web token. Once again, we'll talk about how to fix this and now make sure this doesn't happen for developers in a minute. But this is stuff that most people, when they're implementing JWTs, do not think about the possibility of moving them around and having the ability to forge different claims and things like that. Now, is this always going to work? Maybe not, because there may be claims in there, or there may be missing claims inside the token that we forge or the token that we're substituting that a particular endpoint requires. Let's say there's something silly in there like an upload folder or something like that. Well, if you didn't know that a certain resource needed that, even if you submitted it and you were able to use a token that told the back end you were the administrator, if it's missing a claim that it needs, the request might just fail, okay? So there's a potential there. Those are edge cases. There's a potential there that it won't always work, even when it is vulnerable. But heck, this is a really good thing to try here, okay? All right. Last one here is JSON web tokens and information exchanges. So basically, once again, like I said, this is the catch-all for everything else, okay? Once again, just to kind of reemphasize, JWSs, JSON web tokens, and the JWS signature or JWS format, right? They're transparent and can contain sensitive information, okay? So in most cases, this is not a problem, right? Because the bearer of that token is often the owner of it. Right? So the common question I get is, why can't the person that owns the token be able to see inside of it? I mean, is there anything sensitive in there? Well, there could be, okay? And we'll talk about some examples of that here in just a moment, but I agree, and I think we can all agree that integrity is the main problem. Like, we should not be able to do all the things that we were doing and changing stuff. Like, we shouldn't be able to do that kind of stuff. Integrity is the main problem. In fact, the stuff that we were just doing had nothing to do with integrity. It had to do with substitution. But the first thing I talked about, where we were talking about enforcing signatures, that stuff, right, it just needs to be done. So integrity is the priority. Confidentiality is always not thought of, but it's sometimes an issue. So let's think about where these things are stored. If you're using access tokens and you want your user to be able to close a browser and then like the next day come back and open it and still be authenticated, that thing has to be stored in local storage, like the local storage mechanism in your browser. Local storage is accessible to JavaScript on the client side, which means cross-site scripting attacks can always access tokens in local storage. Any type of remote attack, like if I remotely control your operating system, I can get to those things. If you leave your computer unlocked and I go sit down at your terminal, I can look through your browser, or if you use it at a kiosk, like a hotel lobby or something, or a library or something like that, those things will be there and be accessible. And sometimes they reveal things that not even the bearer should know about themselves, things that that an attacker can use to infer information about other users. For instance, one I came across once was I looked inside of a token and I saw an upload folder. And the end result of the upload folder was an MD5 hash. What do we do with MD5 hashes when we see them? We Google them, because Google's great at reversing MD5 hashes. It doesn't actually reverse it, but just they've indexed so many hash resolutions that they find them. And it ended up being a hash of my user ID, which created a unique folder for every user of the application. Well, now that I knew how that worked, I knew what everybody else's upload folders were too, because I was able to reverse mine, see my ID, sequentially add, subtract to it, create other. And if I ever found path traversal or something like that, then I would be able to access other people's stuff. So that was something that I probably shouldn't have been able to see, because I was able to infer information about other users through it. So things like that are what we really want to try to avoid. And so what if the developer included something inside of a token that should not have been able to be seen even by the user? That's our final demo. That's what we're exploring next. Okay, so let's jump over here and do this. So I'm going to log in with Cooper again. And I'm hoping somebody may have seen this earlier and wondered. If you're evil like me, maybe you did. Okay, so I'm going to go over back to my email inbox, get my code. Wait, I need to go to Cooper. I'm Cooper again, by the way, in case anybody wondered why I was cheating. Okay, Cooper's logged in, and I am Cooper. Going back and looking at it this time around, once again, we have our post request, which gives us our code required, sends back the code token. Here, we actually read the code, and it sends all the one from our email that we typed in, and also the code token back. And then, of course, they give us an access token, which identifies us as Cooper. Now, here's the interesting thing here. Just like when we did our substitution flaws, this is a stateless system. The server side does not remember what the code that it created is. It has to send that information to the client and receive it back in order to know what that was. Remember, everything dynamic within that exchange has to be within the request. That's how stateless systems work. So if you've never thought to actually look at the code token itself, it's got the code in it, okay? So now what happens is when you submit that request and you put the code you typed in gets sent, and then the JWT gets sent, the server looks at the one you typed, the one that's in the code token. If they match, then you've proven yourself. But what's the flaw here? Who has access to that code token? Well, let's go try this out. I'm still Cooper, by the way, and I'm gonna try to log in as the admin. I don't have access to the admin's email address. Just so happens I don't need it, because if I go look at the code token that was sent to me, the code is in it. And I can just take it, place it into the interface, and log in as the admin. Okay? Now, that seems a little bit like, yeah, who's going to do that? 2 people in 2023 did that, because I tested both of those applications. Okay? And it was crazy because they were using SMS, and I knew the guy because one of the developers was a friend of mine, so I had his cell phone number. And so immediately I was like, oh, this is going to be so good. So I just put in his cell phone number, and it obviously texted him the code, right? So he gets the code on his cell phone number, and he's like, that's random. Like, I didn't put that in. Must be Tim. And then like 30 seconds later, I sent him a screenshot of me logged in as him. And I immediately get back a text message that's like, we need to talk. And so we did. And he knew right away. Like, as soon as I showed him what I did, he's like, oh my gosh, I forgot to encrypt the token. That was so stupid of me. Yeah, it was, right? But it's an honest mistake. The dude is a great developer. He's written a lot of really, really good code. He just forgot to encrypt. Because let's look at this. I mean, let's be honest with ourselves. When we look at that, I don't see anything sensitive there, right? QA is never going to find this. Right? And it looks encoded, it looks obfuscated. It's not obvious. It isn't until we crack that code open or token open and look at what's inside of it that all of a sudden we realize, oh, yeah, that's not such a good thing. Okay. So this is another one right there. Just make confidential information stuffed inside these things. You see all kinds of crazy stuff in there. Okay. So what do we do? How do we fix this? How do you tell your clients and the developers you're working with, how do you tell them to do the right thing? Number one, missing signature verification. You gotta verify signatures. Libraries do this by default, so you should never find this vulnerability. Like, this really should be locked down, okay? So that shouldn't be an issue. JWT substitution, a couple different things you can do there. The JWT spec actually includes a claim called AUD, which stands for audience. The whole reason for that claim is to tell the server which endpoint that token should work for, and it shouldn't work for any of the others, okay? So like that code token should only be valid on one audience, and the access token should only be valid on a subset of audiences. The server should look at that, it should include an audience in the token, and then determine who should be able to use it, okay? That would prevent that substitution. Another way to do that is instead of using the audience claim, you could just use a different signing key for every category of endpoint. So the access token has its own signing key. The code token has its own signing key. The activate token has its own signing key. That way, it'll fail if it's not being used in the right place, okay? So there's that. Those are two ways. And then the forgery variant, which was the second variant of substitution we did, you got to validate your input. Anybody here ever heard of mass assignment? It's very similar to that, right? We're just providing a whole bunch of stuff it didn't accept, and it's just taking it and stuffing it right inside of something else rather than actually looking at it and making a decision as to whether or not it should process it. So there's lots of different ways to do that. You can use schemas, data transfer objects, something like that. You just really need to explicitly bind your inputs to a claim set so that you're not blindly accepting a bunch of data you shouldn't accept. And then, of course, encrypt your tokens, right? Like if you got confidential information in them, they need to be encrypting their tokens. That's pretty straightforward. All right, conclusion here. Lots of attack vectors I didn't mention here. All the crypto ones, to be specific. That JWT editor thing that we were using here is a great tool that helps automate some of that stuff. Bottom line is JWT. Like, I love this quote here. Like crypto, what does it say? Crypto standards give users enough ropes to hang themselves. Like just consider JWT a bag of ropes. And it's like, here's JWT. There's all these things that you could do wrong with them. And I'm just trying to shed a little bit of light on that in this particular talk. Yeah, they're a core component of web design. They're not going anywhere. They're basically forced adoption at this particular point in time. So hopefully this has helped you in some way, shape, or form to maybe identify additional vulnerabilities and go make the world a safer place for us all to operate in. But otherwise, that's pretty much all I got. There's some resources. Slides will be somewhere. I'm sure this will be recorded as well. I'll put them up on my website, actually, so you'll have access to them at landmaster53.com as well. Some good write-ups there, some credits and attribution to the graphics that I use, and then some information about me. My training, if you're interested, practicesec.com. If you like what kind of stuff that we did here, my classes are like this. We get into it, we dig deep, we learn about things, and then hopefully we go all make the world a better place.